Welcome to Introduction to Computer Science, Databases and SQL. This is Lecture D. The component, Introduction to Computer Science, is a basic overview of computer architecture, data organization, representation and structure, structure of programming languages, networking, and data communication. It also includes the basic terminology of computing. The learning objectives for databases and SQL are to define and describe the purpose of databases, define a relational database, describe data modeling and normalization, describe the structured query language or SQL. Define the basic data operations for relational databases and how to implement them in SQL. Design a simple relational database and create corresponding SQL commands. Examine the structure of a healthcare database component. This lecture examines the structure of a healthcare database application. The electronic medical record used by the Department of Veterans Affairs, better known as the VA, is called VistA. VistA is an acronym for Veterans Health Information Systems and Technology Architecture. As this architecture supports a nationwide system, the underlying database design is of a significant size. This lecture will look at elements of a single component of the architecture. National Utilization Management Integration, or NUMI, is the component of VistA used to assist when reviews of clinical care activities are performed. Some of the clinical care activities include verification of the patient and treatment information, which confirms that patients met requirements for inpatient admission, review of daily treatment information, and checking whether continuing hospital stay met the clinical requirements. It's also worth noting that the NUMI database is separate from the VistA database. NUMI is populated from VistA, but NUMI does not send any information back to VistA. The following slides examine the workflow supported by NUMI. First, the patient is admitted to acute care. The next step is to examine the length of stay, or LOS. If the length of stay is less than 12 hours, no review is necessary. If it is more than 12 hours, then an initial review is performed. The data is entered into NUMI and into another VA system, the VHA Support Service Center. For each day, the stay is reviewed, and the patient information is reviewed when the patient is transferred to a higher or lower level of care until the patient is discharged. As one might expect, there is a significant amount of information to maintain, along with a complex database design to support storing and reviewing the required information. NUMI has 30 tables in its database to support its activities. Note that these have meaningful names for the database architects, and some are immediately recognizable. Patient, for example, would contain patient information, and physician would contain physician information. The next slides will examine some of these 30 tables in more detail. This discussion will begin with the center of the healthcare system, the patient. Note that for this table, and for all the tables that follow, the examples are from the U.S. Department of Veterans Affairs, or VA, Systems Management Guide for National Utilization Management Integration, or NUMI, written by the architects for system developers and maintainers. To simplify these examples, only a few tables from the NUMI application and only a select number of elements or fields from each table will be presented, which should provide a feel for the database design and relationships without getting lost in too many details. For each table, the column information shows the element, or column name, the data type for the VA database, whether the column is a primary or foreign key, and comments about that element. Each row contains information about this data element in the corresponding table. For the patient table, there is information for about 5 of the elements in the table. You can see the VA System Management Guide for details about all 15 elements. The first element, Patient ID, has an int data type. This field is the primary key for the table and represents the ID number for the patient. Note that the element name is in bold as it is the primary key for the table. The next 3 elements are varchar fields that store the name, sex, and social security number of a patient and are not primary or foreign keys. Sex is often stored as a single character in medical applications instead of as a varchar. The final field is another integer that stores the ID number for the site. The data type is referred to as small int, which is an integer that uses fewer numbers bits than a regular int. This ID is a primary key and foreign key from the site table. This slide shows select elements from the site table. The site ID field, which is the primary key for the table, serves as a relationship between the patient table and the site table. The other two fields relate to the name of the site. One is the full name, and the other is the displayed name for the site in NUMI. This allows for a different variant of the name, for example, an abbreviation, to be displayed within the NUMI application. This slide shows an entity relationship, or ER diagram of the two tables. There is a relationship between patient and site by means of the site ID field in both tables. This is a one-to-many relationship. A patient is at only one site, but there may be multiple patients at a single site, and may be described as is at a. The central functionality of the NUMI application is reviewing a patient's stay. This slide shows a description of the table that stores data relating to the review. As before, only select elements or fields are shown to simplify the example. The primary key of the table is the patient review ID, which is a big int, or an integer that uses more bits for storage than an int. Many of the elements are foreign keys to other tables, which is to be expected in a table for reviews. A review is for a particular patient who has an attending physician, a current stay, a current care level, and a ward location. It also is done on a particular date. This table creates relationships between the patient, physician, patient stay, care level, and ward location tables. Since the patient review table contains several foreign keys, it has many relationships with other tables. This ER diagram displays the other tables that have relationships with the patient review table, namely the patient, patient stay, physician, care level, and ward location tables. The site table does not have a relationship with the patient review table. However, it does have relationships with other tables: patient, patient stay, physician, and ward location. Like the other diagrams, this is representative of only a portion of the full ER diagram and tables within the NUMI application. In the interest of space and simplicity, not all elements of the tables are shown, nor are all the tables shown. Nevertheless, it is still apparent from the diagram how the tables are related to one another. Now, how does this all work together within NUMI? This slide shows a screenshot of a primary review within NUMI. Many of the form fields match the elements in the tables, although some relate to elements that were not shown. The patient name, SSN, and sex come from the patient table. The admit diagnosis and admit date come from the patient stay table. The day being reviewed, the attending physician, the ward, and the current level of care come from the patient review table. When this form is first displayed, several select queries are performed to get necessary information for display. For example, a select query from the patient table provides information for the patient name, SSN, and sex fields. But other fields are blank, such as the drop-down for attending physician. Nevertheless, select queries are needed to populate the drop-downs, such as attending physician. A select query from the physician table will provide the list of physicians for the drop-down. After all the form fields are completed, the reviewer clicks the Final Save Lock to Database button and the form is submitted. When that happens, a new record is inserted in the patient review table using the information from the fields filled out by the reviewer. Even though the patient review ID, patient ID, patient stay ID, physician ID, care level ID, and ward location ID are not visible on this form, they are available for inclusion in the insert query. For example, when a physician is chosen from the attending physician dropdown, the physician ID for that physician is used in the insert query. After the review record is inserted in the database, any additional changes to the fields will require an update query. This concludes Lecture D of Databases and SQL. In summary, this lecture looked at the database tables used in NUMI, the National Utilization Management Integration application used for clinical care activity reviews that is part of VistA, the Department of Veterans Affairs electronic medical record. Some of the fields of these tables were reviewed, along with the relationships between different tables. This also concludes the unit Databases and SQL. 4 basic data operations were identified: retrieval, addition, modification, and deletion. Efficiency of those operations is critical for efficient use of data. How information relationships and data types are maintained in a relational database were discussed in this unit. The design of a simple database was demonstrated, along with improvement through normalization. SQL and SQL data types were introduced, and basic select, insert, delete, and update SQL statements described. Finally, elements of the database design for NUMI, the National Utilization Management Integration application used as part of the VA's electronic medical record VistA, were explored.